Hello, everybody. Welcome to Lake Mac and Renew's webinar, Adding Home Battery Storage. My name's Mel. I am a Sustainability Engagement Officer at Lake Mac Council. And yeah, thank you all for joining us tonight. Before we begin, I'd like to acknowledge the Awabakal people and pay my respects to the elders past, present and emerging. I'm sure a lot of us are on Awabakal land tonight, and I know myself, and I'm sure a lot of you have a great appreciation for how beautiful this country is that we get to live on. I'd like to introduce Andrew Redaway. So Andrew is an energy analyst who has been involved with Renew for 10 years, helping households with independent energy advice. He's also worked for the Australian Energy Market Operator, the Australian Energy Foundation and ENHA. He's trained in solar installation and is a certified passive house designer. So quite an impressive list of qualifications there, Andrew. No, so you've got a brilliant background on solar and batteries and everything electric homes. So I'll let you take it away.
Great. Thanks for coming along, everyone. So we're talking about home batteries today and, specifically adding them onto solar. A fair bit to cover. I'll try and move through it fairly fast. So we've got solar refresher first, because solar and batteries generally work together well. Why batteries? How do they work? Quick note on upcoming rebates, getting the most out of your battery, and some tips on buying a battery, or solar and battery. All right, so solar refresher. Even before we get into the solar, the first thing to mention is the basics. It is important to make sure you're on the best plan, because basically, as with most other things, insurance, etc., the providers have a loyalty tax. So if you're still on an old plan, then it's probably been getting higher and higher. So the only way to get a good deal is to actually, unfortunately, to get out there and shop around from time to time. So yeah, Energy Made Easy is a good Commonwealth Government comparison website. Whatever is another one. And going back to other basics, energy efficiency. So the cheapest energy is the energy that you don't use in the first place. So this is just a picture of ceiling insulation. So we've got those insulation bats on top of the plasterboard up in the roof cavity. And the star rating label, you'd be familiar with on fridges, dishwashers, all that kind of stuff. So yeah, don't forget about energy efficiency. It's not as sexy as batteries, but yeah, it does make a difference. Okay, solar. So we're talking about solar photovoltaic generating electricity. There's also solar hot water. That's a separate thing. We're up to about 1 in 3 homes already having solar, and most solar households are getting a good return on their investment. Things are changing a bit, and we'll come into that. Batteries up till now haven't been that common, so probably only about 1 in 7 new solar installations going in have a battery going in with them. So up till now it's really been, the mainstream has been put on solar, and a battery is a bit of an optional extra, which hasn't had the uptake that solar has, and we'll explain why. Okay, so just looking at solar without a battery to start with. So you've got a panel on the roof, you've got sunbeams hitting the panel, it pushes the electrons around, it pushes electricity down the special cable, and that goes to an inverter. So that's the box on the wall or in the garage usually, which converts that special DC solar electricity into your standard household electricity, 240 volts alternating current AC. So that has a cable that goes into your switchboard, your standard switchboard with all those little safety switches, and then if it's sunny and you're running appliances, then those appliances automatically have the first call on the solar as it's being generated onto the roof. So yeah, you're using electricity directly out of your solar. Now, if you're generating more than what your appliances are using at any point in time, then that excess gets pushed out into the poles and wires. If you're consuming more than what you're generating at a point in time, then the shortfall automatically gets imported from the grid to make the difference. Okay, so solar PV by itself, yep, good direct environmental benefit because it's displacing centralized generation, which at the moment, unfortunately, is still mostly fossil fuel. Solar electricity that you don't use is fed in. So that actually has a direct environmental benefit as well, because that's automatically going into the poles and wires. It's going into your local grid. So your neighbours would be using some of your solar electricity, your excess solar, which is reducing, again, how much electricity has to be imported from the grid. So yeah, exporting electricity does have a benefit. Now, there are a couple of caveats with that. Like in a lot of parts of the electricity grid, we are getting to a stage now where there's so much solar on rooftops and big solar farms out in the country that when it's really sunny, there may be competition between rooftop solar and big solar farms. So at those times, like rooftop solar gets priority. So if your solar system is exporting to the grid, it may actually be reducing centralized generation, but reducing generation from a solar farm rather than from a coal-fired power station, which is obviously not what we want. So yeah, that's one of the changes that's occurring in the system. Okay, now the energy. So this is a question we often have about rooftop solar is, okay, right, it's generating electricity, but it's generating energy, but what about all the energy that was used to make the aluminium in the frames and the glass and the silicon cells and transport it from China to Australia? So yeah, valid question. Yeah, it does take a fair bit of energy to produce and transport a solar panel, but the good news is that that energy used to produce it will be covered within the first 2 years, probably somewhere around there, of generation on the roof. So yeah, good environmental outcome. Economics of solar systems. So the prices of solar systems they've dropped a lot. In recent times, it's sort of tapered off. But actually, this chart's a little bit out of date. The prices have dropped again. So solar panels themselves are cheap. And this is looking at overall solar system installed, and that has, yeah, it's come down a fair bit since, you know, if you installed your solar back in 2011 or something, then yeah, you would have paid a lot to put them on the roof. And there are federal rebates. So this is the Small Technology Certificates, STCs. The good thing about this rebate is this applies to some things, but not others. It applies to solar panels. It applies to some heat pumps. It doesn't apply to batteries. And the rationale was, okay, the purpose of this is to provide an incentive to generate clean electricity. And a battery doesn't actually generate the energy. It stores it and then discharges it back again. But yeah, the good thing about this rebate is it's all covered by the installer. So basically, whenever you're getting a quote from a retailer or installer, then it's already factored in that rebate. Oh, and the other thing is that this STC rebate, it is phasing out down to 2030. So between 2020 and 2030, it's phasing down to zero. So yeah, which is fair. I mean, the purpose of the rebate was to encourage the uptake of solar and kickstart the industry, and it's achieved that. So you don't want to give rebates on things forever, or protection. I guess we did that with the car industry a while back, car manufacturing. So if phasing it out is probably fair. And if you see advertisements saying you have to get in before the end of the year because the rebate's going, well, it's not. It's just gradually decreasing each year. So it's not something you have to rush over. So feed-in tariffs. So when you do have excess solar generation, which gets pushed out to the grid, you are paid by your electricity retailer on your bill a feed-in tariff. So that's not very high. Like the suggestion here is 5 cents. That's it's been going down. So what we're seeing more recently, and probably what you'd expect going forward, is pretty much you're not going to get much at all for the electricity that you send into the grid. And the main reason for that is basically what I mentioned previously, where a lot of the time where there's so much solar, both rooftop and large scale, that there's an excess, and it's like if you have a market for potatoes or whatever. When you have an excess, then there's a supply and demand, and the price for that energy goes really low. So in the wholesale system, if it's a sunny day, then your excess is actually really not worth very much to your retailer. Okay, so economics of solar systems. So you're looking maybe around 5 to 9 years sort of thing, or maybe down to 4 to 7 years if your consumption is higher. So it's a bit of a paradox. Like if you're consuming more energy, then you can maybe get a faster return on your solar, but that's because you're using more of that solar as it's generated. So you're saving the full retail tariff, which could be 30, 40 or more cents per kilowatt hour. So you're getting a lot of value out of that solar if you're actually using it on site. And we'll come back to that. This is another thing to look out for is it's basically congestion in the local grid. So if the poles and wires going down your street are getting overloaded at sunny times, which can happen if there's lots of solar going in, then your electricity distributor, your local poles and wires company, is likely to impose an export limit. So you might go, okay, great, I'm going to put in a really big solar system, like 15 kilowatts. And so you go ahead and do that. You're working with a solar installer. If the solar installer isn't that good, they might not have discussed this with you previously. And then you get it installed, and then you look at your monitoring on how much it's generating. You go, oh, hang on, it's a beautiful sunny day. I've got a 15 kilowatt solar, so I could be generating a power level of 15 kilowatts, but it's actually only generating 6 kilowatts. What's going on? So the reason for that would be that the poles and wires company has put like a speed limit. It's put a export limit on the power that you can export back to the grid. So let's say the power limit was 5 kilowatts, and let's say you were using 1 kilowatt of power within the home at that point in time. So you're using 1, you're exporting 5. That's the maximum your solar system is allowed to generate at that point in time. So even though you got 15, you might only be generating 6. Now, it's usually not that bad because most people don't put in such a massive system. They might put in, say, 7 kilowatts. And the other factor is most of the time you don't have perfect solar generation conditions. Like either it's cloudy, or the position of the sun in the sky isn't like right directly in front of the panels. It might be off to the side, or you might have shading from a tree or a building or something like that. So most of the time, if your export limit is not too low, like if you had like a 1 kilowatt limit or a 5 or like a 0 kilowatt export limit, then that would actually be putting a pretty severe crimp on your generation and on your economic benefits. Now, flexible dynamic export limits. That's another version of export limits, which is already in place in some areas of South Australia, and it's coming in Western Australia, and it will be coming to other states before too long. And that's actually a good idea, because it's like, instead of just having, like, if you think of the example of the roads, instead of just having a 40 kilometre per hour limit, 24/7, what you might do is say, okay, well, most of the time we can have a 60 or 80 speed limit, and we only ramp it down when there's roadworks, for example, or it's a school zone time or whatever. So what that does is, with solar, it allows you to export basically as much as you want. Like, it might be a 10 kilowatt export limit, and then it's only when the grid is actually stressed that that export limit gets applied. So it might be like 5 from 10, 90% of the time, 95% of the time, but then the rest of the time you get like say a 5 kilowatt export limit. So yeah, that's coming, and it's probably a good thing. All right, so getting the most out of your solar. So this is just a chart that says, okay, typical household, you wake up, you put on appliances, you may be cooking breakfast, whatever. Then a lot of households, they're out during the day, not using very much power. Then in the evening, they have another peak. And obviously, this is like a bit of a stylized chart. It's not as smooth as that, because it's actually jumping around as you flick on appliances and lights and all that kind of stuff. So it's a lot more spiky, and it can vary a lot from day to day. It definitely varies a lot from household to household. But yeah, just general concept. So if you've got a solar system, you may be generating a lot of solar around the middle of the day when you're not using much, which means you would be exporting a lot of solar out to the grid, not earning very much for it, and potentially having that cut off, and that some generation being wasted because the poles and wires can't handle it at that time. So what can you do? Well, batteries, obviously, a topic of this presentation, but also hot water. So heat pump hot water systems, which is what we're seeing here. So it's a type of very efficient electric hot water system. So you can use some of your excess electricity from your solar panels around the middle of the day to heat up your hot water, and then use that all through the night, all through the next morning, etc. You could preheat or pre-cool your home if you happen to have a really efficient, like, well-insulated, well-sealed home. And electric vehicles. Charging is a perfect example. If you have the vehicle at home at least 1 or 2 times during the week, that you can take advantage of that. Examples of electric hot water systems. Okay, why would you get batteries? Well, there's a bunch of reasons. Store renewable energy for later use. I mean, that's the basic concept of a battery, home solar battery. Save money on your bills, so reducing peak consumption. So, like, especially if you're on a tariff, an electricity plan that has expensive electricity in the evening, like say 3 p.m. to 9 p.m., that's fairly common, and then cheaper at other times. Then if you can if you are like using lots of electricity during that peak time, then if that can come from your battery instead of from the grid, then that can save you a fair bit off your bill. Tariff arbitrage. So that would be where you might actually want to charge up your battery from the grid when electricity is really cheap, and then discharge it back to the grid. Or just use it in the evening. So taking advantage of that difference in between the cheap grid electricity and the expensive grid electricity. Up until now, that hasn't been a massive, not that many people have actually been charging their battery from grid electricity, but that is starting to happen now. Blackout backup. So when you have a grid blackout, can you keep your home going, and can you run your home off your battery when all your neighbors are dark and they can't run anything? Potentially, yes, and we'll come back to that, but not necessarily. Local grid issues, so the high voltage. So that's coming back to this, where the poles and wires have a bottleneck, and your solar may be curtailed, it may be throttled back. You may have that export limit applied, or actual just a technical voltage issue which your solar inverter sees and throttles itself back. So if you have a battery which is charging up in the middle of the day, then that's going to help with those issues. More energy independence, support development of new technology. Number 8 is to go off-grid. Now, off-grid, what it really, different people have different definitions, but what it really means off-grid is if you've severed your cable going to the poles and wires, and you're running standalone on your own energy resources. And in the suburbs, there's very few households that are doing that, because usually it doesn't make sense. The problem is getting through a week of really bad weather, basically. So if you're not getting much from your solar, how your battery is going to get recharged? Well, yeah, most people who are off grid are out in the bush, where they're building a house and they got a quote to have the electricity connected, and it was like $50,000, because the poles and wires company would have to put in new poles and string new lines and all that. So that's why they've gone off grid. In the suburbs, it's probably not advisable unless you've got very specific requirements. Okay, so virtual power plants. So these are a thing that exists. Not that many people with batteries have actually joined these, but a minority have. So what it does is it's saying you're basically signing a contract with a company. It might be your electricity retailer, or it might be a different company, and they're going to give you some incentives in return for allowing them to remote control your battery from time to time. So they would send a signal to your battery to say, okay, discharge now, please. And there'll be some limits on that, depending on the fine print of the deal, like how often they can do that, and how deeply they discharge your battery. So the point of that is, if the grid gets really stressed, then the grid may need some help to keep everything running. The price of wholesale electricity in the market can spike up to like $19 a kilowatt hour, compared to like, 30, 40, 50 cents per kilowatt hour, which is what we see as households on our retail electricity bill. So many times that. And it's like a stock market. The wholesale price like goes up and down like every 5 minutes. So your retailer, for example, could make a lot of money by or save a lot of money, really, by discharging your battery, which reduces their bill. Your retailer, like Origin or Energy Australia, etc. If your battery discharges to the grid, then it reduces your retailer's bill for buying that electricity on the wholesale market. So that's a benefit they get, and so they provide you an incentive, like either some regular payments through the year, or it might be a cheaper, like a discount, a rebate off your upfront price of your battery. So a good idea in theory. Anecdotally, a lot of householders are a little concerned about the transparency of those deals for a VPP. So if Big Brother is going to mess with my gear and remote control my battery, then how do I know that they're doing it fair? Are they making more out of it than what I am? Am I getting a good deal? It's hard for householders to have a lot of transparency in those sometimes, but yeah, in concept, they actually are a good idea. Okay, so why? Yeah, a couple of factors of batteries. So sustainability. Okay, so are batteries green, or are they reducing CO2 emissions? Um, Depends how you look at it. It's not just a yes or no answer, unfortunately. So what a lot of people think is, okay, I've got solar on my roof, so that means I'm not importing from the grid during the day because the solar's covering it, but I'm still importing from the grid at night. So if I put in a battery, then now I won't be importing from the grid at night. Well, usually, maybe sometimes, but I can really cut down my nighttime consumption as well as my daytime. And yeah, that's true. But if you just look at it that way, what you're missing out on is, without the battery, you're actually exporting a lot of electricity, which in most cases has an environmental benefit. And so if you're charging up the battery, you're losing out on the benefit of the export, but you are getting the benefit of reducing your import from the grid at night. So yeah, if you're looking at it as a direct, like, short-term benefit, it's not a huge one. It's going to improve over time as there's more instances of excess solar during the day, like through the whole electricity system. Yeah. And of course, another way of looking at it is, well, if we want to get to a 100% renewable grid, then we definitely need a lot of energy storage in the system. So if I, as a householder, if I'm putting a battery in, then I'm being part of that solution. I'm doing my bit to contribute to that overall solution. So that's a valid way to consider it if that's how you see things. But yeah, there are some indirect benefits. So yeah, if it's in those cases where you do have excess solar, then yeah, it can actually allow extra renewable generation. Economics, it varies a fair bit. So until recently, like, it was most household solar and battery systems. Well, if you look at the battery payback of just the battery component, it was not many of them would reach payback within 10 years. So just the benefits of adding that battery on would be unlikely to, over 10 years, would be unlikely to add up to the overall cost of installing the battery. So, okay, what price are we talking about for batteries? Let's take an example, probably the one most people have heard of, the Tesla Powerwall 2. So yeah, it's just an example. There's plenty of other batteries out there around the same sort of size. So you might be looking at around $15,000 to for the battery and the installation and have it all working. So you might be putting that on a solar system, say, I don't know, 15 panels or something. That might have cost you $7,000 for the solar. So there's two components which you have to be aware of what the different prices of them are. And adding that battery, it may be costing you twice as much as what adding the solar panels cost. So yeah, solar panels by themselves are going to provide an economic benefit and probably pay themselves off pretty well. So adding the battery is an optional extra, and is that optional extra, is that going to pay for itself? And until recently, generally we would have said probably not. It's much more likely to pay for itself within, say, 10 years if your home has high energy usage, you're on a time of use tariff, like, yeah, Ausgrid area. They go up to 50 something cents per kilowatt hour during peak times. So yeah. If you have lots of excess solar, so you've got a big solar system, if you've got harsh export limits, like throttling back your generator at sunny times, etc., then those are the cases where it was paying for itself. Okay, so here's some tips on the actual installation. Okay, so blackout backup, right? So not specifying that can be a pitfall. Just a note, by the way, this picture is for fairly typical high capability off-grid solar system. So someone's installed it in a shed. Those are all the batteries down the bottom. You've got the battery inverter on the wall there with the square box with the yellow label, and then you've got the two solar inverters on the wall. So that's a big battery, and so that would be a good capability if you wanted to run like off grid. You've severed your cable to the grid, then that's the sort of thing that you're looking at. But you still may need a generator as well if you have like a week or two of like really cloudy, rainy weather. Yeah. So most households in the suburbs aren't going to go to that extent, right? They'll just have like a smaller battery, like maybe the size of one of those cabinets, one of those BYD cabinets there. And yeah, they may just have a single inverter, which is their solar inverter, and the battery goes straight into it. And that would be more typical in the suburbs. Okay, so blackout backup. Yeah, you need to really be clear on this with the installer that yes, we do want to back up the house during a blackout. How much of the house do we want to back up? Is it going to run everything? Like even if you turn on your aircon and your oven at the same time, is it going to be able to handle that? Or more likely, is it only going to be some circuits, some appliances in the house which gets backed up? Because yeah, if you go too crazy with your power during the blackout, then you might exhaust your whole battery capacity like quickly, and then you're blacked out again. Other questions are, if we have a blackout, are we going to have instant changeover over to the battery, or are we going to be in the dark for like a few seconds or 30 seconds or something? May not be a problem, but in some cases, maybe it's a consideration. And a big one is, will the battery be able to charge from the solar during the blackout? So let's say you have a blackout at night, your battery successfully run your house through the nighttime, but it's getting a bit low by when the sun comes up. Is that battery going to get more charge from the solar while the grid's still down? So yeah, that's another good question to ask as well. Inverter limit. Yeah, so sometimes your poles and wires company may say, oh look, you're only allowed to have like a maximum of 10 kilowatts of inverters in your home connected to our assets, our poles and wires. And you go, okay, that's fine. My solar inverters are only 7 kilowatts. I'm under the limit. But then if depending on how the battery is configured, if it has its own inverter, say a 5 kilowatt inverter, so now we've got 7 plus 5. That goes over 10. So you may not get permission to connect that battery into the grid, and that's something the installer would handle. By the way, is that paperwork with the poles and wires company. So that's another thing to watch out for. Location problems. We'll come back to what the Australian standard says. Batteries don't like getting super hot. It will probably reduce their lifespan. So watch out for if it's outdoors on a west-facing wall which gets hot sun like every summer afternoon and evening. Yeah, that's not the best. Yeah, watch out for you don't want to put in like a $15,000 battery and then crush it the next day with your car bumper, do you? And oh yeah, hot location, but also cold location. Like if you're getting down below say 5 degrees and so, then just be aware that the battery's power level to charge and discharge may be automatically reduced to protect itself. So ideally you don't want it getting, down towards freezing. Warranties, of course, as with any sort of, big expense. Yeah. All right. So Australian standard requirements for battery installation. So this is basically due to fire concerns. Now, how important are the fire concerns? Well, I'm sure everyone's heard about scooters and hoverboards and cheap electric bikes and the dangers with those batteries. Like home storage batteries are better than those. We're talking about a more expensive item which does have better engineering, proper battery management systems in it. So yeah, you don't have to be as concerned as like a scooter battery. But yeah, it still has to be done properly, and the requirements in the Australian standards are basically you can't put it in your living room. And so you're probably looking at either an external wall or in a garage. So if it's on an external wall, then you can see in that diagram there, like that BESS is the battery, and the grey shaded space is like the clear space required. So you can't have pretty much anything in that space, like windows, hot water units, gas bottles, air conditioning unit, all that sort of stuff. Yeah, so yeah, that's basically what you're looking at. So in some homes, it can be hard to find like a location for a battery that actually meets the Australian standard. Okay, so just some comments here about saying just be aware of what you're getting into, because it is more complicated than putting on solar system. There are more pitfalls. Basically, you're probably going to be spending more money, and it doesn't last as long either. Is another thing with batteries. So you're probably looking at 10 to 15 years of lifespan out of a home solar battery. The panels on the roof, you're looking more like 20 to 25 years of lifespan. And the panels on the roof, like the solar inverter that they feed, maybe 10 to 15 years, but that's a relatively inexpensive component. So yeah, just think about whether it really is worth it for a home solar battery. So there's some calculators, etc. here, and some calculators down the bottom. We've got guides and information here. I'm sure Doug in the background is good at providing some of those links in the chat. Okay, now what's some of the newer and more innovative things that are going on? All right, well, I've already mentioned like wholesale electricity prices in the national energy market. So national electricity market. So sometimes they spike up to crazy levels. Sometimes they go negative. So if you can get access to those wholesale prices, then when it goes negative, for example, on a sunny day when there's maybe it's a public holiday, for example. So in the electricity system as a whole, there's not much consumption going on, but there's a lot of generation from rooftop and large scale. Then you can actually get paid to use electricity. So if you can get access to those, that could be pretty interesting. And there are starting to be electricity retailers with plans, household plans that pass through those wholesale prices to you. So the only example I'm really aware of at the moment is Amber Electric. They've been around for several years now. Got quite a lot of good reviews. So check them out. I'm not involved with them at all, but they're the only example at the moment to really mention. So yeah. So what they do is they pass through that wholesale price, and they pass through the poles and wires costs. So it would be Ausgrid or Endeavour or Essential Energy, and they add on a margin to obviously to cover their own cost as a retailer and to make their profit as a private company. So yeah. Anecdotally, there are people with batteries and potentially other things as well, like some automation to turn off some of their high consuming appliances during when the wholesale price spikes up. Like, pool pumps, hot water systems would be obvious. You could go further and turn off your aircon for 20 minutes or whatever if the price is spiked up. And yeah, they're actually making money. So instead of paying a bill, they're being paid by their retailer. Now, it's not for everyone, because if you do have that high price event where it goes up to $19 a kilowatt hour, and you use like 10 kilowatt hours at that rate, then yeah, that's a pretty big potential cost just for not many hours of electricity consumption. So watch out if you go for one of these plans. Like, see if there's some sort of safety net there, and like so Amber, they do have a safety net. So what they do is like, on individual like half-hour intervals, you may be paying that really high price for your electricity imported from the grid. But they provide a safety net over a whole month. So they look at what they're about to bill you for a whole month, and if that is going to be higher than a standard electricity tariff, electricity plan plus a bit, then they'll just cap it at that level. So yeah. Something to be aware of. And personally, I think this is going to become more popular and more common for households in the future, just because it makes a lot of sense, and the opportunities are there, especially as we get more smarts in our batteries and our appliances and everything else. Okay, so another upcoming opportunity is vehicle to grid. So if you have an electric vehicle, it's got a big battery in it. Okay, so household battery, you may be looking at 10 or 15 or 20 kilowatt hours of energy storage capacity. An electric vehicle, you're probably looking at 30, 40, 50, 80 kilowatt hours. So you're talking multiples of, maybe 5 like solar batteries in one car. And if you were going to buy an electric vehicle anyway for transport purposes, then if it has the features to do this, then you're basically getting a storage battery for free, because you can use that one asset for 2 different things. Now, there's some caveats. You can only use it as a home storage battery when the vehicle is at home. So that's one thing. But yeah, when the vehicle is at home and it's plugged in with its standard charger, if you've installed like a home wall charger, if you're going to install that wall charger anyway, so you probably, including installation, you may be looking at maybe $2,000, $3,000 for that. Then in a couple of years, I'm actually expecting that there's going to be wall chargers which are capable of doing that, have the bidirectional capability. So bidirectional, charging the car and discharging from the car, and there'll be cars with that bidirectional capability, and the price premium is not going to be that much over over just a one-way power to just charge the car. So yeah, now in the example picture here, it's assuming that there's an inverter built into the into the wall charger, but that's the expensive way to do it. The cheaper way is to use the charger which is already in the car. So in that case, the wall unit, it doesn't have to. It just has to have some more smarts, really, and the car has to have some more smarts, so it can export out to the grid with the same kind of, playing nice with the grid that a home solar battery and a solar inverter do already, right? So just as long as those additional electronic components get built in, it really shouldn't cost more than a few $1,000s, I would think. Additional cost to be able to use that car as a very big home solar battery. So let's say you were paying a few $1,000s for that additional capability. That's cheaper than like buying a home solar battery, which might be, $10,000, $15,000, and it's a much bigger battery as well. So I do think that this is going to take off pretty quickly once the capabilities come in. So what's holding it up? Well, standards, right? So the car has to communicate with the charger. That's the real bottleneck. And Charon is the organization that does that standard. It sounds trivial, but with electric vehicles, we have a case like right now where there are some car models that were sold a couple of years ago. If they try and, or is it only a year ago? They try and plug into the new Tesla superchargers, which have been opened up not just from Teslas but to other brands as well, and they don't work. So that's just the simple version of this, where you're just charging the car and you already find compatibility problems. So when you go back the other way, so now we're exchanging power both directions, it gets more complicated. So it's actually not trivial for every brand of car to be able to talk with every brand of charger and deal with the grid as well. So that standard, international standard, is expected to be in place in next calendar year, and then it'll probably take a year for the products to start flowing out onto the market. I do think it's going to happen. So the question there is, well, if I'm thinking of getting a home solar battery now, do I do that, or do I wait for a couple of years and see? Because I was thinking of getting an EV anyway. I was going to upgrade my car. So do I wait and see if I can get a bidirectional EV? Everyone make your own choice. I mean, if you have real sort of needs or super urgent desires for a home solar battery now, then go for it. Personally, I'd probably be inclined to maybe save up my money for now and aim to make my next car a EV, which can hopefully go both ways. So now a couple of notes about batteries. So this is the same sort of diagram we had before with the solar. So the solar is feeding the solar inverter, and now we've got this battery that's plugged straight into the solar inverter. So that's actually one of two ways that you can connect a battery in. So this is called DC coupled. So you've got solar coming in with direct current DC, and your battery is coming in with direct current DC as well. And that one solar inverter is doing everything. So that's simple. It avoids having extra inverters, which may cause hassles with your poles and wires companies. It makes it easy to store excess solar. Like if you put on a big solar system bigger than what your inverter can actually handle, then to send out to the switchboard, it may be able to send some of that excess into your battery. So all of that's good. Downsides, you're still limited by the power of that solar inverter. So if the solar inverter is a power limit of, say, 5 kilowatts, then that's the most that it can put out. Even if you got sun falling on your panels, and your battery could also potentially do, say, 5 kilowatts. So you could maybe get 10 kilowatts, but you got that bottleneck of the inverter of 5. So if you had lots of appliances on, then using, say, 8 kilowatts, then you still end up importing some power from the grid. The other option is where the battery has its own inverter, which is separately connected into that switchboard. So that's called AC coupling. So, for example, that's what the Tesla Powerwall does. So that has the advantage of, like, when it's sunny, you might get extra power, like solar and battery simultaneous. And it's also easier to add on later, because if you've got one of these inverters now and you say, okay, I'm going to add on a battery, and you call up the solar installers, then the risk is they go, oh, okay, you've got the 2024 model of that inverter. It's now 2028, and yeah, we don't have any batteries that are compatible with that anymore because the technology's moved on. So that's one issue, and the other one is standards. Like, if you wanted to swap out your existing solar inverter for a one that you can plug a battery straight into, hybrid inverter as they call it, then your solar installer might go, oh, I don't know, your solar was installed by this other mob, and we don't really know exactly how they did the cabling in the walls, and the standards have changed for the cabling and the isolators, and if we start, like, messing with your existing solar system, then we're basically going to have to end up replacing the whole system to bring it up to current spec. So yeah, it's usually easier if you are retrofitting a battery onto an existing solar system to go for a battery which has its own inverter, which might be built in like a Tesla Powerwall, or it might be like a separate inverter next to it, which gets connected direct into the switchboard, not messing with the existing solar. Okay, so there's a bunch of information resources there, just about batteries. I've also got the price benchmarks down there. So Solar Choice, yeah, they've got some interesting over time, like how prices have moved on batteries. Rebates. Okay, so in New South Wales, due to be available 1st of November. So you're looking at a rebate of 1,600 to 2,400, depending on the size of the battery. And there's an additional component there if the battery is connected to a virtual power plant. Were you paying attention? Do you remember what a virtual power plant is? So it's basically where you're giving permission to an organization to remotely control your battery and discharge it to help the grid and make some money for themselves from time to time. So the intention there from the New South Wales government is they if they're going to be subsidizing batteries, they want them to be providing maximum assistance to the overall electricity system and overall, like, overall population. Yeah, so that's why they're providing that incentive as well. All right, getting the most out of your battery. We've seen this chart before. So now, so this is the general sort of how most people are operating their battery. So you've got this excess solar in the day. At least some of that you're charging up your battery, and then you're discharging that later in the evening to reduce how much you're importing from the grid, and maybe also the next morning. So that simple operation, if you're going with one of these new emerging retailers that I mentioned, where you can play on the wholesale market, then your battery would have automatic like logic in it, and would have access to information on the wholesale price, so that it could well be charging up at times from the grid if it's like if it's getting paid to do that. So it may be doing other things other than just charging up around the middle of the day. All right. Now, how are we going for time? All right, we just got one little section left. So some tips on buying these things. So the tips are similar, like for solar or a battery, like same sorts of things you want to consider. So how much you're actually spending on energy. You might throw in petrol in there as well for if you're considering going from a petrol car to a EV as part of your overall sort of equation. What sort of appliances do you have? Like, so maybe you might want to switch from gas hot water to electric hot water, and then that can tie in with your new energy system as well, solar and batteries, etc. What are your priorities? What do you want to achieve? Do you have a lot of excess solar generation, or maybe would you install extra solar to if you were going to install a battery, so you'd have more energy to charge it up? And yeah, is there a place to install a battery, like taking into account those Australian standards? Okay, so retailers and installers, probably two separate companies that you're going to be involved with. So the retailer is the one who's advertising, who's giving you a quote, selling you the system, but these days they're unlikely to be the same company that's doing the installation. So they're probably subcontracting to the actual tradies who are going to do the work. So you've got a retailer and you've got an installer. So anytime you've got subcontractors, I mean, it's the same with, like, if you employ a builder and they subcontract, a plumber, for example, to do part of the work. There is that potential for miscommunication or passing the buck. Like if a problem happens, then the retailer might say it's the installer's fault. The installer says it's the retailer's fault. Now, like, most of the time it's not an issue, but it probably is a good idea when you're dealing with the retailer, like, ask them, okay, so if a problem happens, you're gonna take responsibility for the whole thing, right? Which is what they're actually meant to do. In terms of approvals, you've got an approved seller, which is like a status under the New Energy Technology Consumer Code. So if a retailer has that qualification, then they've signed up to a code of conduct where they take responsibility for the whole job. There's a whole bunch of other things about advertising, communication, and all that stuff, quotes. So that's a good indication. With installers, the key thing really is accreditation as a solar installer by the Clean Energy Council, and that is an individual person. So if you've got installers coming, I would actually be asking them, okay, which of you is the accredited installer? Because they're meant to be there at the job, at least during the key stages of the job. They don't have to, but they are allowed to leave and come back and have their assistants, like, doing some of the work, but they do have to supervise it pretty closely. So it's good to be aware of that. Okay, we mentioned that. Word of mouth, just like with any major sort of home improvement, like installing a deck or a pool or whatever. Warranties, yep. Multiple quotes. So there are companies out there that can make it easy to get multiple quotes. So you contact them and they're referring on to their network of installers. or retailers, I should say. Okay, how do you minimize the risk of getting a cowboy installer? And again, like this is not picking on the solar or the battery industries. It's, you know, any industry that there are some cowboys out there. Okay, so when you're dealing, yeah, how do they vet their subcontractors? What steps do they take to make sure they're doing a good job, training, etc.? Is there a good clear quote where the panels are going, where's the battery going? Is there going to be a site visit before the quote? Actually, that's rare. That's rare at the moment, at least for solar. Most of the time they're doing a quote just based off aerial photography and other data like that. But if a company is coming out for a site visit before they provide a quote, that's a really good indication that they're going to do a conscientious job. Okay, so the installer, are they credited, as I mentioned? Will they be present? Brand and model of the panel, battery, and inverters. So there have been cases where the panels or the battery that have turned up haven't been the same model as what was quoted. Now, it may be innocent. It may be just that since the quote was done, there's now an updated version of the same product, and that's what the wholesaler provides now, and it's actually better than what was quoted. So that's okay, but yeah, you don't want a switcheroo for something which is actually not as good or not as suitable as what was quoted. So check that. When it comes to panels, they're actually meant to provide you the serial number of every panel, and I would definitely be asking that for a battery as part of the information that they provide. Yeah, what is the model? What is the serial number? Just check everything's right, and is everything going where you expected it? And like panels on the roof and battery, like where is it going? You might have expected it over here, and then the installer has decided to put it over there, which maybe you don't like the way it looks, or there may be some other issue. The installer may have good reasons because they've discovered an issue which wasn't apparent when the quote was done. So I would say be involved with the installer. Like, you don't have to be looking over their shoulder like for the whole job, but just have that communication flowing and checking that everything's going the way it should. And the cables. So you've got cables from solar panels to solar inverter. You've got cables from the battery to either the solar inverter or to the switchboard. So are those cables going where you want it? And are they going inside a wall cavity, or do they have to go inside like a plastic conduit on the outside of the wall? So talk to the installer. There may be some options there. And yeah, is it all working, including the monitoring? So pretty much every system these days, like there's an app or there's a website where you can check how it's performing. If at all possible, get all of that stuff working before they leave. And yeah, documentation, obviously warranties. A lot of that is electronic, like PDF documents rather than hard copy. But yeah, you should have all of that. Warranties. Okay, so for batteries, after 10 years, typical would be you would have like 60% to 80% of the usable capacity still remaining. So yeah, you'd expect some degradation, but that should be specified in the warranty. Product warranties, you maybe get 5 to 10 years on a battery. Yeah, battery may also mention like cycles. So how many times is the battery cycled? So that would normally be from a full charge to a full discharge. So if the battery on average, if it's only going down 50% and then back again, then like each day, then it would take 2 days to equate to one full cycle. So yeah, just see, well, okay, if you look at the cycles as well as the years, like am I is the warranty likely to last for as long as what I expect it to? And then the installation warranty is the installer saying, okay, if we stuff something up, then we'll come back and fix up our workmanship. Okay, that's end of the presentation. So I think it's time to head over to questions, I think.
Yeah, that was great, Andrew. Thanks for that. There's really is so much to adding a home battery. I don't know that I'd ever really thought about how complex it is and how much goes into choosing the right battery and right installer. So we've got a few questions come through. So if anybody does have any questions, just pop them in the Q&A function. So our first question is, I have recently bought a home with solar. Do rebates apply to upgrades? Thanks.
Okay, so there's the rebate on the solar panel. That's the STC rebate. Usually it does. Yeah. So let's say you're adding new solar capacity. So you're probably adding a new solar system alongside the old solar system. So yeah, you'll get that rebate. If you're replacing solar panels with new ones, then probably, but it'd be good to check before that goes ahead. And with the batteries, with the New South Wales rebate that's coming up in November, then adding that battery onto an existing solar system would qualify for the rebate. Yeah.
Excellent. Next question is, can I install a battery directly onto a weatherboard cottage, or do I need to build a brick wall to install onto? There's no garage, just a carport.
What the installers are normally doing is they're putting fibre cement, like a big sheet of fibre cement, like, a fair bit wider than the battery and a fair bit higher, onto the wall and then putting the battery on. So yeah, that's fairly quick and easy to do. You don't need to build a brick wall. So just be aware of that. Obviously, how it looks and things may be a question, like depending on where the battery is. But yeah, that's doable.
Excellent. And you mentioned during your talk to carefully check if a battery is the right thing for your home due to cost, appropriate location, etc. This person, they've been delaying for 7 years to get a battery as technology has been moving so fast. Is it still worth waiting because they're getting cheaper, but will there be superior designs in the near future? It sounds like an EV might be a better option once the capability in our system is here.
Yeah, that's a good question, and there's a lot of people in the same boat as that. You haven't really mentioned what your motivation is. If you get a lot of blackouts in your area because the power lines supplying your house go through like bush with like lots of big gum trees just waiting to fall on it in the next storm or bushfire or whatever, then that might be a consideration why you want to get a battery. And especially if you've got multiple people at home and the EV might not be there. If it's environmental, then that's a question. Batteries, the environmental benefit is not as clear as solar panels or probably electric vehicles, I would say. If it's just purely about bill saving, then look, it's a fair investment, like to put a battery on. So whether it's worth it or not, look, like I said, look, how close are you to pulling the pin on an EV is the other question. So if you were thinking of getting an EV anyway in, say, 2 or 3 years, then I'd maybe lean towards saving the money and and then making a choice in 2 or 3 years. And if those EVs that can discharge back into the house are available, then yeah, I think I'd probably lean that way.
The EV charging back into the house definitely seems like pretty good setup.
Yeah. It's there's already pieces of the puzzle that are available. So most EVs that are being sold now can actually discharge out of the battery into a extension cord.
Oh
So
wow.
yeah, so that's called vehicle to load. So you could, if you're out camping, you could run appliances off it, or if you had a blackout at home, you could put an extension cord from your car into your home with a power board, and you could run your fridge and your laptop and your router and a couple of little gadgets and stuff.
Yeah.
So that's already there. So if cars can already do that, uh, Teslas don't do that yet, by the way. But most of the Chinese ones do.
Yep.
Well, actually, the Teslas here are Chinese, but most of the Chinese car brands can do that and vehicle to load already. So if cars can do that, then how much of a step is it to go to the vehicle to home, a vehicle to grid? And yeah, there's case studies like in the Netherlands, the city of Utrecht. They've done it with a bit of a customized system. Yeah, full vehicle to grid. Like they've got multiple cars discharging into the grid and being paid for it. And the Tesla Cybertruck it's the first Tesla car that's got this vehicle to home capability. And yep, that works with a wall charger that's pretty much the same as their standard wall charger. So everything's moving that direction, I think. Yeah.
Yep. Yeah, that's awesome. Our next question is, can batteries be charged by off-peak power?
In general, yes, but the main sort of limitation there is the software and the logic that's going along with the battery. So yeah, just check with the company that's selling it, like make that really clear that you want that capability. But yeah, they can.
Our next question, now it's not quite battery related, but what is your opinion or knowledge on the reliability of heat pump hot water systems, and are they worth swapping over? If they're as reliable. So we'd like to know.
Yeah, sure. Yep. Not a chemical battery, but a tank of hot water is like a thermal battery. Yeah. Except the only thing you can use that energy for is your showers, pretty much. But yeah, no, it's very valid, and a tank of hot water is way cheaper than like a home solar battery. So yeah. Okay. So reliability of heat pump hot water systems. At my old place, yeah, had a heat pump hot water system, still going strong. Many years later. Depends on the brand, I would say. So yeah, if you talk to plumbers, they often tend to say, oh yeah, heat pump hot water, they're noisy and they're unreliable, and but often yeah, I would ask them, okay, well, what brands have you had experience with? And usually they're talking about some of the cheaper brands and some of the earlier brands that were available.
Yeah.
So yeah, I don't want to get super brand specific, but if you look at the technologies, there are different. So heat pump hot water systems, they use a refrigerant gas, like in the lines that go through their system, like a air conditioner or a fridge, right? So the refrigerant gas, there's like the older, more standard gases, like your old aircon would use, and then there's the more recent ones like propane and carbon dioxide. So the heat pump systems that use carbon dioxide, they're by all sort of reputation over the last decade or so, they're very reliable. So there's about 3 on the market at the moment. So yeah, might as well just mention them. There's Sandon, there's Reclaim Energy, and the other one, I think it's Ream. Maybe someone can correct me on that, or Doug can look it up maybe if you got time. so those heat pump hot water systems, they do have a separate compressor, like it goes beside the water tank. It isn't like built in on top of the water tank. But if you're looking for maximum reliability, those are probably the ones I would suggest looking at. That they tend to be more expensive, but yeah. And there are some other ones that are pretty decent as well, but you just have to do your research basically. There definitely are some heat pump hot water systems which are really good.
Nice. This next question, I think, might be more directed for me. It's a Lake Mac one. So, you mentioned in your talk companies offering to buy excess power from households. Is Lake Mac Council considering being one of those buyers? I haven't heard any talk at work of this just yet, but again, in the future, I don't know what direction Lake Mac will go, but I know they do have a large focus on renewables and solar and all of that. So I think that's probably a little bit in the future for us. And asset optimization, I reckon we'll have a better idea of that than me. But yeah, sorry, that's like a bit of a vague answer.
No, in my current job, I deal with a lot of councils as clients, and I'm not aware of any that are really looking to jump in and like be like an electricity retailer and like interact with their residents on that level. It's more. Yeah, it's more the organizations that are doing that are more like, your Origin Energy, your AGL, Tesla, those sorts of energy companies that operate in the energy space. They're mostly doing it.
Yeah. And we have a maths question for you now. So this person, they've got 31 panels and 3 inverters, with a total of 9 kilowatts.
Right.
They're in their 70s, and with subsidies, will a battery, if they had a battery, will it pay for itself in 5 years?
Okay, let's think. So
I hope I've said that right. If I've said it wrong, if they can write in and correct me, that's okay.
Yeah. So, well, let's see. Let's say you got a battery that costs $10,000, and you get a subsidy of about 2.4 thousand, I think, for that size battery, roughly. So that might bring it down to 7,500. So if it's going to pay for itself in 5 years, then you've got to save, the battery itself has got to save about $1,500 a year. Well, how much is your electricity bill at the moment? Is it 1,500 or less? If it's less, then it's really unlikely it's going to do it, unless maybe you go with one of these innovative companies that enables your battery to like trade on the wholesale market. In that case, I do think it's got a chance. But yeah, that does come with a little bit of risk. You have to be satisfy yourself that there are some safety nets there for you, and you have to read the fine print. But if you just go with like a standard battery offer that's just doing standard things, I think it would be unlikely, to be honest.
Right. Well, before everyone jumps off, I think that's all our questions, but I just wanted to say, if you are interested in electrification and energy efficiency, We've got Tim Forsey coming to Lake Mac on the 23rd of August. So, Tim is the creator of the My Efficient Electric Home Facebook page. So, I'm not sure if anyone's a member of that. It's a really great Facebook page. It's a good community where everyone can ask all their sort of questions about electrifying their homes, and everyone gives really great answers. And Tim has recently written a book and is on his book tour. So you can come along to that event if you like and meet him and have a chat. And there'll be some other experts there as well. And oh, yeah, you're going to come?
No, I was just going to put in a plug for Tim Forsey. I worked with Tim back in like 2012 at the Australian Energy Market Operator. We were both working there. He's very knowledgeable, and go along if you can.
No, we've had great things, so it should be a really nice event. And if you are new on your all electric home journey, Lake Mac Library now has a like a power audit kit you can hire. So it's got an infrared camera in it and energy measuring device, so you can go through your home and see if you've got any drafts, or if your fridge is leaking any cool air out, and that's costing you extra energy. You can use this kit to go through your home and see what appliances might need upgrading or fixing. It's a really great resource. So pop on the Lake Mac Library website if you're interested in that. And we also have induction cooktops for rent through the library. So another great resource if you're looking at upgrading to induction, or you're not sure of its capabilities, or you just want to give it a go, you can borrow one of them from the library. Yeah. Andrew?
I feel like you're the school teacher. There was a question that just came through that Doug's given a quick answer, but so it was a question about community-based batteries. Community batteries. It's a thing. There are some up and running, and there's more scheduled to go in. So you're probably talking like 500 kilowatt hours compared to like 10 or 15, say, for a individual home. So you're looking at like something the size of a, four-wheel drive sort of car, probably on a little bit of council land, usually the case. So it's connected straight into the poles and wires, and there's a lot of debate about whether they are a good way to go or not. So at the moment, they've been a little bit underwhelming, I would say, in terms of the benefits that they provide. They do have the potential to do better with some costs come down, which battery costs are expected to come down actually over the next year or two. If you look at the utility scale batteries, really big batteries in shipping containers, lots of shipping containers out in a paddock somewhere, their prices have already come down, like almost halved in the last couple of years, and that's expected to flow through to the smaller scale batteries as well. So that would help them. And if there's some reform around the regulations about what sort of tariffs, what sort of plans, electricity prices that they can get with the poles and wires, especially, that would help. Some companies are putting them up on poles rather than like on an electricity pole, rather than on a bit of land somewhere, which helps a lot with the costs. One of the criticisms is that they're not really operating as a community asset. Like people often think, okay, if one of these goes just down the road from me, then I can like subscribe to it and it will give me exactly the same benefits as if I put like a home solar battery on my wall of my house. And when I look at my bill, like it'll automatically deduct off like from my excess solar as if I had the battery. That's not happening anywhere. That's a nice concept, but really they're operating more as an asset, like for like private operation in the energy market, or as an asset like for the poles and wires company. So the community benefits are more about like improving the quality of the local grid so that more solar systems can be installed, and you're not getting your solar inverter switching itself off because of the power quality in your local street. Those are more of the benefits that are happening at the moment. So yeah, at the moment they've been underwhelming. I wouldn't pin your hopes on them. Yeah, I'd think of them more as an asset that's going to generally like develop the grid rather than something that you're going to be able to use as a household.
Excellent. All right. Well, I think that is. Oh, someone would like to know, why aren't more local governments getting into this? Oh, I think it's hard to say, but I think it's definitely a moving wheel, and change takes time, particularly in government at times. So I think a lot of governments, local governments in particular, are pushing for more of this. So I think in the next few years, you'll see a lot more local governments in particular jump on this type of stuff. Yeah.
Can I say a lot of local governments are getting into this in their own assets, like in terms of council buildings, vehicle fleets, all that stuff. But I guess you'd have to question whether it's a core business of local government to like be out there like becoming a battery retailer or an electricity retailer, or yeah.
No, I know Lake Mac, we have a lot of I think our whole building is solar powered now, and we have a power purchase agreement so that if we are purchasing power from the grid, it's always renewable. And we've got a pretty big fleet of EVs, electric vehicles now as well. So yeah, definitely trying to keep up as the technology comes out. Well, any plans to add blower door test kits to the library of things? I can definitely look into that. That's library of things is something I help out with, so I'll add that one to my list. Thank you for that.
I could probably answer that one a bit if you like, Mel, because they're extremely expensive, like $7 or $8 grand, and you need extensive testing, training to do it. Which I'll drop a link in.
Blower door test kits.
Yeah.
Okay.
They're awesome.
I'll do some research, because if it's something the community is interested in, I mean, like Mac's always happy to invest in different webinars or in-person events, I should say, and see what we can do.
Library of things, like I'm imagining it like the room of requirements in Harry Potter.
Yeah, it's a lot of councils are doing it now. Ours is just kicking off with the power test kits and induction cooktops, but there should be some more things being added. I think things like say a sewing machine or a toolkit, things like that you might only need for a one-off event, you can just go and borrow them instead of having to try and buy or get someone else to do it for you. So that should be brilliant. Alrighty. Well, thank you everybody for coming along and listening to our webinar. And thank you, Andrew and Doug. You've both been great. Doug's been so busy in the chat. I know a lot of people want the links. They will be sent out when we send out a recording of this. So you'll have them in a week or two, hopefully. But yeah, hope everyone has a good night, and thanks for joining us.